Hello friends, in the previous class we learned the theoretical part of linear programming of method for solving the games, and in this class we will be discussing an example to learn properly how the method works. So consider this example: solve the following game by LP method, and this is a two-player zero-sum game, and A1, A2, A3 are strategies of A1, B1, B2, B3 are strategies of player B, player A and player B, and this is the payoff matrix. So here we can see some entries are negative. So as discussed earlier, okay, we must add something so that all the entries are positive. So adding 4 to all the elements in order to make them all positive. Therefore we have, so what I did, I simply added 4 to all items in this matrix. So I get a new matrix, or we can say now we have a new game to be solved. Okay. Now the LPPs of both the players are, for player A, it is maximize U is equal to minimize 1 upon U is equal to x1 plus x2 plus x3, subject to the constraints. This is column wise. The constants of player A will be written column wise. You can see here 5, 7, 10. Okay, the coefficients will be column wise. Whenever you write the coefficients of B, the constraints for B, the coefficients of the constraints will be row wise. I'm not saying this, but this is the formula that we have learned in the previous class. So according to that we will be writing. Okay, so 5x1, 7x2, 10x3 greater than equal to 1. Similarly, these three constraints and these x1, x2, x3 are greater than equal to 0, whereas this xi's are nothing but pi's upon u. Okay, this we have also learned in the previous class, right? So now for player B, he wished to minimize his maximum expected losses. So minimize V is same as that of maximize 1 upon V, and this is equal to y1 plus y2 plus y3, subject to the constraints 5y1, 3y2 plus 7y3 less than equal to 1. You can see from here 5y1, 7y2, 10y3 less than equal to 1. Here all the constraints are of less than equal to type. Right, so these are the two LPPs. Here U denotes the minimum expected gain to player A, and V denotes the maximum expected loss to player B. Now solving the LPP of player B using slack variables, we get the following table. Yes, this is important point. You can see this player B's LPP is having maximization of objective function, and all the constraints are of less than equal to type. Therefore, we will solve this, or one should solve this, because in the earlier, that is player A's LPP, all the constraints are of greater than equal to type, and that will be a cumbersome situation where you have to subtract the surplus variables as well as add the artificial variables. All right, so yeah, now the solving this, so what we get, if you transform that or try to solve that, I'm sorry for a minute, try to solve that player B's LPP, then you add surplus variables and apply simplex method to solve, and at the end I am showing you the final table. When you reach at the final table, you have this situation. Okay, here all the zj minus cj values are positive, hence it is an optimal stable or optimal solution. And what the optimal solution is for player B, the value of variables is like this: y3 equal to 1 over 10, y2 equal to 1 upon 10, and y1 equal to 0. Okay, similarly we can read the solution of other player from solving this LPP by principle of duality, like that the variables or the values of Zj minus Cj under the slack variables are the values of the decision variables of the primal problem or other problem. That is, here we can see x1 equal to 2 upon 50, x2 equal to 1 upon 15, and x3 is equal to 0. And the value of the gain, okay, that is the value of the objective function maxima 1 upon v. We have been considering this, and this is simply what the cbyb, and 1 into 1 upon 10 plus 1 into 1 upon 10 plus 0 into 1 upon 5, and this we get 2 upon 10, that's 1 upon 5. This implies, because 1 upon 5 is equal to 1 upon v is equal to 1 upon 5, therefore v equal to 1 upon 1 upon 5, that is equal to 5 only. So this is the value of the new game that we have made, okay, with by adding some constant to the previous payoff matrix. Now coming to the value of the original game, as told earlier, value of the new game minus the constant added, that is 5 minus 4 is equal to 1. This is the value of the original game. Okay, now just finding these pi's and qi's. So also yj equal to 0, y2 equal to this and this. This I have told you. Say therefore there is a relation between yj and qj. We have learned earlier that yj was equal to qj upon v. So therefore qj is equal to v into yj. So this is just like v is 5 and yj, y2 is this, and y3 is this, and v is this. So we are getting this and that. Okay, now therefore the optimal mix strategy to player B is B1, B2, B3. These are the strategies, and corresponding probabilities of choosing them strategies is provided by this method, LP method. So these are the probabilities, and this is the optimal strategy. And yes, so similarly you can find out this P1, P2, P3 for the player A. So this is again, I told x1 equal to 2 upon 15, x2 is equal to 1 upon 2 upon 15 and 1 upon 15, and x3 was 0. So therefore this x1 into v and value of the game, and similarly this into value of the game and this. So you are getting optimal strategy to player A as 2 by 3, 1 by 3 and 0. Okay. So this is how this method works. I just told you, right? So thank you very much.